isotopic radiator. This article needs additional citations for verification. February 2013. Learn more. An isotopic radiator is a theoretical point source of electromagnetic or sound waves which radiates the same intensity of radiation in all directions. It has no preferred directions of radiation. It radiates uniformly in all directions over a sphere concentrated on the source. Isotopic radiators are used as reference radiators with which other sources are compared. For example, in determining the gain of antennas, a coherent isotopic radiator of electromagnetic waves is theoretically impossible, but incoherent radiators can be built. An isotopic sound radiator is possible because sound is a longitudinal wave. The unrelated term isotopic refers to the radiation which has the same intensity in all the directions. Thus, an isotopic radiator does not radiate isotropic radiation. In physics, an isotropic radiator is a point radiation or sound source at a distance. The sun is an isotropic radiator of electromagnetic radiation. Antenna theory. An antenna theory is a hypothetical antenna radiating the same intensity of radio waves in all directions. It thus is said to have a directivity of 0 decibel relative to isotropic in all directions, since it is entirely non-directional. It serves as the hypothetical worst case against which directional antennas may be compared. In reality, a coherent isotopic radiator of linear polarization can be shown to the impossible. Its radiation field could not be consistent with the Helmholtz wave equation derived from Maxwell equation in all directions simultaneously. Consider a large sphere surrounding the hypothetical point source in the far field of the radiation pattern, so that at that radius the wave over a responsible area is essentially planar. In the far field, the electric field of a plane wave in free space is always perpendicular to the direction of propagation of the wave, so the electric field would be tangent to the surface of the sphere everywhere the continuous along that surface.